Hello guys, this is Group 3A representing on Chapter 3 of Human-Computer Interaction, and the topic is requirements gathering. So displayed on the screen are the group members, as you can see. So at the end of this video, there are certain objectives that we would like to be met, and the first one is that you fully understand what requirements gathering entails, the various classifications of requirements, and as well as eliminating ambiguity in system designing. So since you're talking about requirements gathering, what are types of requirements? So a requirement is a statement about an intended product that specifies what the product should do or how it should do it. In other words, it's a necessary condition or demand, meaning that when you talk about a product being manufactured, what at all do we want the product to do? What do we require it to do? What do we need it to do? So in that case, we're talking about what we need, the function that we need the app or system or whatever we are designing to perform. Okay, so to gather the requirements that we need, there are three steps that we have to undertake. The first one being data gathering activities. And when you talk about data gathering activities, you're talking about the undertakings or exercises that designers pursue in order to get information from people that will be using the app, people around the environment, and every other form of exercise they take to gain information. So after gaining the information, now there's analysis of the information, which is talking about carefully looking through the information and sorting out, filtering out the information to get the correct data and information that we need. And from that, you're able to express the information gathered as a requirement, meaning that you've gathered the information, you've analyzed it, and now you've been able to get the requirements that you need out of that information. So requirements can be classified into three categories, basically. The first one is functional requirements. So when you talk about functional requirements, you're looking at services that are specified for the system to be designed, meaning that we're looking at what the system should do, how it's supposed to react to certain inputs. So from an input, what is the output that it's supposed to give? Basically, you're talking about what do I want the system to do? So based on functional requirements, an engineer determines the behavior that a system or a software or a device is expected to exhibit in the case of certain inputs. Just as I said earlier, based on a certain inputs, it's expected to give out a particular output. So we also have non-functional requirements. So non-functional requirements are attributes or constraints that judge the operation of a system rather than its intended or specific function. All we are trying to say here is that apart from what the system being designed is supposed to do, that is the intended function, how should it do it? Okay, so the difference between functional requirements and non-functional requirements is basically what should it do versus how it should do it. So some of the criteria or the constraints or the attributes that we look at when talking about non-functional requirements include security. So assuming the system we want to design is a software, how secure is the software you want to design? If it's taking user details, how would it protect them from being, stolen and all forms of fraud as we already see going on? Performance, how fast is the app? Is how manageable is it, like compatibility? Can it work on multiple platforms? How reliable is it? Is it easy to use? There are certain apps you see them, they are very useful, all right. They're very capable apps, but then when you look at the interface, it looks and feels basically very difficult to understand. So there are certain things that the people don't have to tell you, or the client doesn't have to tell you, but you should know that there are things that I have to do to make the app easier to use. Okay, there's also maintainability. Assuming there's a crash or something, how would it be repaired? Is it easy to repair and all that? So we also have domain requirements, and domain requirements basically talk about the environments in which the system is being intended to work in. So, for example, if it's in a medical field, if it's in a business area, we're talking about the environments in which the system being designed is intended to work in. and it can be functional or non-functional. So, we'll use this example to classify the various requirements, being the functional, non-functional, and domain requirements. So the functional requirements is saying that when an order is fulfilled, the local printer shall print a packing slip. So in this case, basically, we are saying that the functional requirement is a system that prints out information. Okay. Then you look at the non-functional requirements. It's saying that packing slip shall be printed on both sides of a 4 by 6 inches paper, the standard size for packing slips. So we're saying that how should they print it? How should they print the information basically? And that is, it should always print on both sides of the paper. So the functional is saying what it should do. It should print. Now the non-functional is saying how it should do it, saying that it should print on both sides. The domain requirement is saying that the functionality of being able to specify different paper sizes. So as I said earlier, the domain requirement has to do with the environment the system is intended to work in. So when you look at a school, for example, you realize that even this university, let's use this university, um, we print exam papers, posters, you know, you realize that they all come in different sizes because they are meant for different purposes. So at each situation, what are we expecting the system to be able to do? So basically, as the environment changes or as the situations change, how is the system able to keep up? Basically, then look at the basis for system requirements, and from the diagram we are seeing, is showing that the stakeholder requirements serve as the basis for system requirements. So when you talk about a stakeholder is basically anyone, whether sponsor, user, any or organization even, that has direct or indirect influence on the system design. So the stakeholder requirements express the intended interaction a system will have with its operational environment, and that are the reference against which each resulting operational capability is validated. And the system requirements specified from the supplier's perspective what characteristics, attributes, functional and performance requirements the system is to possess in order to specify stakeholder requirements. All this diagram is saying that the stakeholders affect the outcome of the system, or they determine what the system needs basically. So there are forms of requirements gathering, and we'll be looking at 10 of them. The first being affinity diagramming. So it's also known as affinity mapping or space saturate and group, and it's a participatory method of writing concepts or ideas on cards and sorting them into groups and subgroups. So um, I think I should assume that we all watch movies. You watch these kind of mystery murder movies, and you see detectives. They've piled up a list of suspects. You realize that they've made this whole board and they've pasted names, linked them together. That's that whole board that we've been seeing that they've been using to, you know, draw ideas and to find, let's say, the mastermind or criminal is a form of affinity diagramming, and it's usually used in brainstorming sessions. So affinity mapping allows um, a designer, to interpret data from clients and users to determine the range and set boundaries to a problem, and to determine the relationship between multiple problems or ideas. So, as I said, when we watched movies and you see these detectives drawing conclusions from this diagram, they use the diagram actually to determine the relationship between, the problem, the solution basically, and find ways of solving them. So it allows you to properly, sort out data and interpret it well, to set boundaries and find the relationship between, well, the problems or ideas involved. So on the slides are two examples of affinity diagrams. So when you look at the left side, It's a traditional, or let's say Odin days style of affinity diagramming, when they've taken a sticky notes and they've just written onto it, and they've categorized the ideas that they have. While on the right side, it's a digitalized version where they've used the software to develop the affinity diagram. So the second thing we're going to look at is ethnography or field observation. So ethnography is a qualitative research method used to study people and cultures. So in this case, it's a qualitative research method that is used to study people, or sorry, study workers on the field. So the idea behind field observation is for a designer to go to the workplace and observe how the workers normally go about their normal activities at the workplace. And whenever a field observation is being conducted, the designer should not be obtrusive or distracting to the workers. So there are certain methods that they use to gather information during the field observation, and some examples are taking pictures, taking notes, and also recording videos. But then the video recording is not always appropriate in some situations, or it's not always applicable in some situations. For example, when you go to the hospital and there's an emergency situation or there's a surgery being conducted, you will not be allowed to record videos. So in certain situations, the video recording is not actually appropriate or applicable. So ethnography allows you to properly understand the context in which the system is to be used, as well as discover certain factors that may have been overlooked in the design. So what I'm saying here is that since with field observation, the designer actually goes to the workplace to study how the workers go about their normal activities, it gives you a clearer picture or understanding of what they want the system to do in the workplace. And during the requirements gathering or requirements given from the stakeholders, there are certain factors that they may have overlooked or forgotten to mention. But because you actually go to the field to study how activities or how things are done at the workplace, you will be able to find certain um, information or certain factors that were overlooked, basically. So the third one we're going to look at is persona. And a persona is a fictional representation of an actual user, his or her approach and expectations in using the system. It's a technique that supports designing interactive systems mainly focused on end users, and user profiles of people are created for this purpose. So, with personas, we talk about imagining an actual person, like a real world person. So, for example, you take, let's say, it's a library system for students and a librarian. So a library booking system basically. The librarian and the the students are not personas, but in this case they are rather user roles. But then when you talk about personas, you're talking about, let's say, Emmanuel being a student. How would Emmanuel use the system? Let's say they are talking about a real world person, not a role in the app. So that is one thing you should note, that a persona is different from a role. Is an actual person, and personas allow you to understand what a user to understand the user and what the user would actually want. So with personas, since you're taking actual human beings, we talk about different temperaments of a person. So for example, you have Emmanuel, who is a very impatient person. How would Emmanuel be able to use the app and get satisfied? You talk about another person. How would that a person who is calm, a person, you're talking about different scenarios of each individual and how each individual would um use the system. So this is an example of a persona with um a man called Clark Andrews. You see that you're giving detailed information about a particular person, not the role of the person. So it's taking it from the point or point of view of a particular person and how the person would use the software. So the fourth thing I'm going to look at is stakeholder interviews. So as I said previously, stakeholders are people that directly or indirectly influence the design of the system. So examples are the end users, the clients, or and the sponsors. So with stakeholder interviews, you deal with those who have a direct or indirect influence on the app. So interviews are set up to get information from these stakeholders. So it says that interviews are conducted to determine basic needs of the stakeholders, basically. So there's a guideline in which you can follow, or there's a guideline in which can be followed to get the actual, or should I say, proper information needed. So the first one is to aim to get the basic needs or basic facts. So with this, you're basically talking about gathering precise or concise information. If they told you they want the system to do a particular purpose, ask questions that are linked to that purpose in order to get a clearer view or understanding of what the stakeholders want. And you can also review interview questions with colleagues to develop customized scripts. So over here, we're just talking about um, gathering a group of people and trying to get um, the perfect, should I say, perfect set of questions that you can ask the users. You should plan for follow-up questions during interviews. So depending on the inputs given by these stakeholders or these users, you can give them follow-up questions since they are obviously not all going to give you the same answers. So you can give them different questions or follow-up questions as the interview goes on to see each user's input. And you should also design a form in an easy to fill format, which you're talking about um, you, the interviewer, designing a form in such a way that you can easily fill it and gather information. So the fifth one we are going to look at is brainstorming. So brainstorming is a group technique in which efforts are made to find a conclusion for a specific problem by gathering a list of ideas spontaneously conducted or contributed by its members. So from the name, brainstorming is just a group of people who have come together and they've gathered to think about a problem and find a solution to it. So with brainstorming, there's an overseer or facilitator who oversees the session, and they're used in answering what if and blue sky questions. So certain scenarios are put forward, and the people involved or the team involved all come together and bring about ideas on how to solve these questions. So in brainstorming sessions, tools like whiteboards and mind mapping softwares are used. So I spoke about affinity diagramming, in which I said was used in brainstorming. So over here like this, in brainstorming sessions, affinity diagrams could also be applicable. So the sixth technique we're going to look at is scenarios and use cases. And scenarios are used to describe one or more instances of interaction with a system under certain conditions and constraints. And they are used to provide information about the context in which a system would have to operate in a user and task-oriented way. All we are saying is that scenarios focus on how a user would perform the intended tasks of the system under certain conditions. So at condition A, how would the user, or what would be the user's approach in performing the task? At condition B, how would the user use the software to perform the task, and what would be the outcome? So in scenarios or conducting scenarios, use cases are used, since use cases consist of the actor being the person who is going to use the system, the goal, which is the functional requirements of the system, and the system itself. So a use case describes the functional requirements of a system from an end user's perspective, allowing developers to have a clear or goal focused sequence of events to follow. So what we're saying here is that since the use case allows the the user basically to perform a function or perform the function of the system under various conditions. At each condition, the developer is able to narrow down a sequence of precise steps that he or she would use to perform the to design the system basically. So this is an example of a use case diagram where a bank customer is going to withdraw money. So it allows the developer to work out scenarios. So if the person is to, or the customer is to withdraw money, what would the customer have to do? What are the various steps involved? So this all allows the developer to work out a series of steps. So he knows that, okay, first to withdraw the money, there has to be authentication. There has to be a form of validation, which is the PIN and account control. So with all these, you realize that the more you work with scenarios and use cases, you're able to narrow down or gather concise and precise steps involved to use the system. So it allows the developer to basically narrow down and simplify the usage or the design of the system. Looking at the Delphi, we're also looking at the Delphi technique, which is also known as the estimate stock estimate technique. So it is a systematic and qualitative method of predicting by collecting opinions from a group of experts through several rounds of questions. And it relies on experts who are knowledgeable about certain topics so that they can predict the outcome of future scenarios. So we are talking about gathering experts and giving them um, a situation in which their inputs will be taken, and from their inputs we will find a solution as well as um, predictions that can be used to solve future problems that can arrive from that problem. And with the Delphi technique, there's anonymity in which the experts do not know the other experts involved in the session. Even if they do, they don't know that they are involved, or they don't know that this opinion is from this expert, or this opinion is from this another expert. With the Delphi technique, there are steps involved. With the first one being identification of the issue. So after the issue has been identified, now you have to find a group of experts who would brainstorm on the issue or give their inputs on the issue, as well as a facilitator who will oversee the whole session. So after the issue has been identified and the experts and facilitator have been gotten, a questionnaire session is conducted between the experts on the problem and their inputs are taken. So based on their inputs taken, another questionnaire session is conducted. And with the second questionnaire session, the inputs of the other experts are given to other experts of, so let's say during the questionnaire session for round one, basically the inputs of the experts are flipped between each other so that each one views the other's opinion. And in this case, it allows the experts to think more and even possibly get a better understanding and enhance their inputs. And another one is conducted again. So it's like a questionnaire session is conducted. They get the inputs of each expert. Another one is conducted. They get an updated inputs from the experts, and another one is conducted again to get another updated inputs from the experts. So this is an illustration of the Delphi technique where the facilitator oversees the whole session and the experts are giving questionnaires in which they give their feedback on over 3 times so that it's at every point they are able to have a new, or should I say updated opinions, and ultimately arrive at the final report. So another technique we're going to look at is usability benchmark. And with usability benchmark, we use um we use a benchmark basically. A benchmark is a metric system, or should I say, it's a reference point that we compare things against. So the benchmark usability measures the current stability of a system to provide a baseline against which future systems can be compared. So what we're saying here is that with a usability benchmark, a system is taken which is used as a reference point. So the system to be designed is compared to that system in order to improve, like to find improvements, flaws, and weaknesses that will help in the design of the new system for like a better design. So the goal is to collect data which will serve as benchmark, and as I said, a benchmark is more like a reference point. So although measures are most often of user performance to cover all aspects of the usability, they should also include measures of satisfaction. So what we are saying that even though we are focusing more on performance, we should also focus on how um, it makes the system easier to use, how it makes it easy for the users to use so that they feel satisfied at the end of the day. So this is an example in which you're focusing on. So this is an example of phones that are being used as benchmarks. So we can see um, a list of phones in which serve as the references under which all other phones are compared to help them better design like newer phones with better implementations and all that. Another technique we are going to look at is studying documentations. And documentations basically are records of an existing system that give specifications or details about the system. So with this technique, you're going to find similar systems or comparable systems that relates to the system to be designed, and from that we are going to um, use the information deduced or gotten from that documentation to help design or help better design the system. So with studying documentations, you just take similar systems or comparable systems, and from the information gotten from them, it helps you to better implement the system to be designed. And the last one I'm going to look at is prototyping. So prototyping deals with creating a miniature version of the proposed system in order to test all possible functionalities and fail-safes of the system. It depends heavily on the users of the system, as the users provide the requirements which are utilized by the analyst to test the system. So with a prototyping, it's more of an iterative process where the first prototype serves as a stepping stone for the second prototype. So it all depends on the user, as the user is the main focus, because with prototyping you are developing a fake model. Okay, you're developing a model that is to help get user input on how to make the system better. So it's not the final product yet, it is the product in its early stages so that you get the users to give you their inputs, which helps you to develop a better system. So the last prototype serves as the model to build the system. So prototyping, as I said, is iterative. So the more you prototype, the more the system becomes better and better. So the last prototype will serve as the basis on which the final model will be designed. So all in all, Requirements gathering or gathering requirements is very crucial for system design, and it helps narrow down requirements of a system and how it would be used. So when you gather requirements, it helps you to get a clearer picture from the stakeholders, and in this case avoid ambiguity. So I would advise that whenever you are designing a system, you should engage in as many techniques as you can in order to get a clearer understanding of what the stakeholders would want. Thank you very much. This is Group 3A.